continue with congruent triangles. Now in grade 8 you were introduced to congruent triangles. In this lesson we will revise the properties again, and then we will continue with more advanced problems. Right, so what is congruent triangles? Now congruent triangles are triangles that have the same shape and size, like this four over here. Now two triangles are said to be congruent, which mean actually exactly the same, if sides and angles of one triangle, sides and angles of one triangle are congruent, right, to the sides and the angles of another triangle. Right. Now we say if sides and angles of one triangle are equal to the corresponding mean matching sides and angles of another triangle. Now I'm going to show you that this PQR fit exactly on ABC, right? It's a perfect match, and you can see there, okay, and AB is exactly the same length as PQ, BC exactly the same length as QR, and AC exactly the same length as PR. So all three sides of the one triangle fits perfectly on all three sides of the other triangle, and for that reason we can say AB is equal to PQ, BC is equal to QR, and lastly AC is equal to PR. Now what about the angles? Here you can see P and A, they are equal. Angle Q and B, they are equal. And R and C, they are equal. Right? So angles A is equal to angle P. Angle B equal to angle Q. And angle C is equal to angle R. So here we have 6 elements of congruencies. The 3 sides fit and the 3 angles. Right, so in these 2 triangles there are 6 congruencies, sides and angles. Now according to the rules of congruency, it actually tells us that it's not necessary to verify congruency of all 6 elements. Under certain conditions, we can verify the congruency of only 3 elements. Now, if all 3 sides of one triangle fits on all 3 sides of another triangle, then they are congruent. Right, but it doesn't work the same with 3 angles. And I will show you why. Now, although the angles of triangle A, B, and C and triangle PQR are equal, they are not congruent. And the reason for that is this side. That side is 54 millimeters, that side is 48 millimeters. Triangle PQR will never fit exactly onto ABC, and I'll show you. Look at this too. Here we have a copy of PQR. And there you can see, right, they do not fit at all. Right, so they are not a match. PQ is much shorter than side AB, the same with QR. And for that reason we say at least one pair of corresponding sides must be equal to prove congruency. Right, now in this triangle here, ABC, this side is 48 millimeters, and this triangle QPR is a copy of that one. So this side is also 48 millimeters, and this angle is 110, that one is 30, and that one is 40, and it will be a perfect match. And for that reason, we cannot be, or congruency cannot be proved using only angles. That's very important. Congruency cannot be proved using only angles. You must at least at least one pair of corresponding sides must be equal. Okay, now there are 4 rules to check for congruent triangles. They are the SSS rule. That means side, side, side. Then B, we have the SAS rule. That is side, angle, side. Thirdly, we have the AAS rule. Angle, angle, side. And lastly, right, RHS, right angle, hypotenuse, and side rule. Now we start with the side, side, side rule. Now they tell you here that triangles with 3 pairs of equal sides are congruent. So if we can prove now that all 3 sides in triangle ABC are the same as the 3 sides in PQR, then these 2 triangles are congruent. Right, which means the 2 of them must be able to fit on top of each other perfectly. Let's see if each side has a matching partner. And we can see here, now we always write it out like this. You first say in triangle ABC and triangle PQR. Right, so because we're talking about a triangle ABC first, we write there that information first. And PQR second, we write that information secondly. So we say AB, yes, is equal to QP. Remember, they are marked the same. And because they are marked the same, they are given. That's the reason. Given. Then, AC is equal to RP. Look there, they are marked the same. And it is given to us. Thirdly, BC is equal to RQ. Also given. Therefore, now we have 3 dots. Therefore, triangle ABC is congruent to triangle PQR. And we give the rule side, side, side. So that is our first rule. All 3 sides of the first triangle is equal to all the corresponding, which mean the matching sides of RQP. Second rule. This time we have the SAS rule, side, angle, side. Now the triangles with 2 pairs of equal sides and a pair of equal included angles, right? Included angles are congruent. Now here I have 3 figures for you. The yellow lines mean they are the same length. The red line and that red line the same length. So here we can see AB and DE, they are equal. BC and EF, they are equal. And 43, that's the included angle, because it's in between that 2 equal sides, right? In between. So these 2 triangles, they are congruent. Now look at the third one. We also have 2 sides that are equal to that 2 sides in length, right? GH is equal to DE. HI is equal to EF, but because of that included side, this included side is not the same as this two. Look there, over there, that's 43 degrees. So for that reason, this triangle will never fit perfectly on this one or that one. Right, so we say here, triangle GHI is not congruent with DEF or with ABC. Now, if we can prove that two sides and included angle in triangle MNO, right, or equal to two sides and included angle in triangle PQR, then the two triangles are congruent. We only need to give three elements, right? And they must be SAS, side, angle, side. And the angle must be included in between the equal sides. Right, we start. And we say, in triangle MNO and PQR, we start like that. In triangle MNO and PQR, MN is equal to PQ. Why? It is given because it is marked. Right. NO, this one here, is equal to PR, given. And lastly, angle N, from there to there, in between, from there to there, is equal to angle P, given. And because of that, what we say here, therefore, triangle MNO is congruent to PQR. And this time the reason is side, angle, side. Next one. The angle, side rule. Triangles with two pairs of equal sides. No. With two pairs of equal angles. Two pairs of equal angles. And one pair of equal corresponding matching sides are congruent. Now look at this. This is side AB, that is side DE. Then we have two angles. 70 correspond with that 70, 60 with that 60. Now, how do we know that AB and DE, that they are matching sides? We can actually see that opposite this angle is AB, and this red line is a side of angle A and angle B. The same over here. This side is opposite F, and 60 degrees and 70 degrees. This red line DE, it's a side of this 60 and it's a side of that 70. So these two, they are matching sides. Right, now we get to the third one. We also have an angle of 60. We also have an angle of 70. But this is not a matching side. This side is only an arm of 70 degrees. It is not an arm of 60 degrees. So for that reason, JKL is not congruent with ABC or with DEF. It will never fit perfectly onto one of these two triangles. So if we can prove that two pairs of equal angles and one pair of equal corresponding sides in triangle MNO are equal to two pairs of equal angles and one pair of corresponding sides in triangle PQR, then the triangles are congruent. And we start again in triangle MNO and PQR. MN is equal to PR, it's given. Angle O equal to angle Q given. M is equal to P. M is equal to P over there. And they are, and the reason for that is given. And for that reason, or therefore, triangle MNO is congruent to triangle PQR. Angle, angle, side. Right. Fourth one. RHS rule. Now, if the hypotenuse, now what is an hypotenuse? Right. That is the longest side of a right angle triangle, and also opposite. It's opposite the right angle. Right, hypotenuse. If the hypotenuse of and side of a right angled triangle are equal to hypotenuse and corresponding side of another triangle, the two triangles are congruent. So you can see here, the longer side and the longer side, they are equal. Another side equal, and then we have our 90-degree angles. So these two triangles, they are congruent. The reason RHS. R for right angle, H hypotenuse, and S means another side. Right. So, last one. If we can prove that the hypotenuse and the side of right angle triangle MNO are equal to hypotenuse of and corresponding side in triangle PQR, then the triangles are congruent. And we start again. In triangle MNO and PQR, MO and PR, MO and PR, they are equal because it's given to us. Alright, reason given. Angle N is equal to angle O because they are right angles, but I'm sure you can say even given there also because, I mean, both of them, they are marked with this little box. Then lastly, NO. NO is over there, is equal to RQ, and that's also given. And therefore, triangle MNO congruent to triangle PQR RHS. But sometimes you have a 90-degree angle, and these two sides of one triangle is equal to the same two sides of another triangle. This time the hypotenuse is not marked. So, in a right angle triangle, congruency can also be a SAS case. Side, angle, side. And a 90-degree angle is included there. If the right angle is the included angle. So it's not always right angle, hypotenuse, side. It's only if the hypotenuse is marked, then it's RHS. But sometimes the 90-degree angle is included into the other two sides, then it's SAS case. So here we have a worksheet, so we are going to practice now. So they say, state whether the following pairs of triangles are congruent. If they are, identify the theorem that supports your conclusion. So they only want to know if they are congruent and why you say that. So your answer can be one of the four cases. So in this case, we have two triangles, and we have one side that belongs to both of them. Triangle ABC and ACD. Now we first see what is given to us, and from there we work. Okay, we have a side there, and that side is the hypotenuse, right? Then we have another side. Okay, we say that is that side. Then we have a 90-degree angle. Right. So it can only be RHS, which means that triangle ACB is congruent to triangle ACD because of right angle, hypotenuse, and another angle. I have the reasons there for you. I'm not going to go over that again, but it's because of the right angle, the hypotenuse, and because of the other side. Right. Now we have the next one. We have a side there. Right. Again, we have two triangles. Right. Two triangles. We have RQ. RQ belongs to both triangles there. Okay. So we have a side there. They are equal. We have this side and that side. They are equal. So now we must look for the third one. Now the third one can be a choice between a side and an angle. Right. There's nothing to show us the sizes of these angles, but we know that this side belongs to PQR and it belongs to QSR. So it's side, side, side. Right. So PQR is congruent to RQS. Reason, side, side, side. And I have it there for you. Okay. Next one. Let's see. We have this two, they are parallel, they are not equal, right? Or it is not marked as equal. They are not marked as equal, but this side and that side. Okay, so we have a side here. So what else do we have? Right, from your previous knowledge, you know that when two lines intersect, we get two vertically opposite angles. So we have an angle also, two angles that are equal. Then thirdly, now we need to know if the third one is a side, is the third one an angle, right? No, we can't say anything about the sides, but we can say something about the angles because we know these two lines are parallel. Okay, so you see there, right over there. So here we have a pair of alternate, that is alternate interior angles because MN is parallel to PQ. So we have actually two angles and we have a corresponding side, a matching side. Okay, so MNO is actually congruent to POQ, and the reason there, the correct order is angle, angle, side. Right. And then we get to the last one. Okay, what do we have? We have a side, right? We have another side. This side is equal to that side. This side is equal to that side. What? Now, we don't know anything about these two sides, but we know that these two angles, they are vertically opposite angles. And look there, they're in between the two sides that are marked the same. In between the two sides. Right. So we have two sides and an angle, and we say triangle AOB is congruent to triangle COD, reason, and that is the correct way of writing it, side angle, side. Right, side, angle, side. And I have it here for you, in case you didn't understand it properly. AO and DO. AOB, COD is because they are vertically opposite angles, and CO is equal to OB because it is given to you. Alright, that must be in between brackets. Next. Now you must prove the following angles are congruent. You must write out your proofs in the required format. So you'll have to start by saying in triangle ABC and ACD. That is how we start. Now they also tell you that in the following figure, AD is parallel to BC and AB is parallel to CD. So you think immediately of corresponding angles, alternate angles, and co-interior angles, right? Prove that triangle ABC is congruent to triangle CDA. Right, let's see what we have. Right, so these two sides are parallel, and we can call that now a transversal also. Right, so immediately you know here we have an angle, there we have an angle. They are the alternate interior angles, and they must be equal because they're in between these two parallel lines. Then we have more parallel lines here and there, which mean that this angle from this parallel line to that transversal must be equal to that angle over there from the parallel line to the transversal. But this time it's because AB is parallel to CD. So we have two angles, right? And this side here, this side AC belongs to ABC and to ACD. Right, so we have a side also. And we start. We can start with any one of that three. Right. So what do we say here? In triangle ABC and triangle CDA, AC is equal to AC is common. So that's this side here. AC is equal to AC. It means that AC in the one triangle is equal to AC of the other triangle. Right? And in that case, the reason is common. Common. Right? Common. Then number 2. Angle DAC. DAC. This one is equal to ACB. Now the reason, alternate interior angles, but also because AD is parallel to BC. Then BAC, this one is equal to ACD, also alternate angles, alternate interior angles. But this time it's because AB is parallel to CD. So we have a side and two angles, and for that reason, or therefore, triangle ABC is congruent to triangle CDA, and we write it in the correct order: angle, angle, side. Right. Now we get to B. In the accompanying figure, MN is equal to OP. There, they are marked the same. So, same length. Prove that triangle NMO is congruent to triangle NPO. Right, let's see. We have a side, yes, we have a side there. We have a right angle there. And this side, you see there, it's opposite 90 degrees. They're opposite. So this is your hypotenuse, right? And it belongs to both triangles. Okay, so in this case it's right angle, hypotenuse and side. So we can start with saying that in triangle NMO and triangle NPO, please, you must name the two triangles. NO is equal to NO. Now you know already. If it's equal, then the reason is common. Then MN is equal to OP, also given. And of course, M is equal to P, right angle, or you can even say given. For that reason, therefore, triangle NMO is congruent to triangle NPO. And this time the reason, right angle, hypotenuse, and side. Right, in this figure, BD here is equal to CD. Prove triangle ABD is congruent to ACD. Right? Let's see what we have. We have side. The side is equal to that side, so we have a side. We have an angle. Okay, we have an angle. And of course the side here is common. Side, angle, side. Is the angle between the two sides? Yes. It's in between the two sides. It's included. Right. So, we start. In the same story, in triangle ABD and ACD, BD is equal to CD, right? And it's given to us. AD is equal to AD because it belongs to both triangles. Reason, common. And lastly, ADB is equal to ADC, right angles. For that reason, ABD, triangle ABD is congruent to triangle ACD. Reason, side, angle, side. Although we have 90 degrees here, it's not right angle, hypotenuse, side. It's not that one. No, it is side, angle, side. Right. Now over here. Okay, let me just get my highlighter before I start. Now in this diagram, triangle BAC is equal, no, let me just see, angle BAC, this angle BAC is equal to BDC. These two angles, they are equal. And DBC, this angle here, is equal to ACB, that one there. So they mark the two equal angles here with Y, and that too with X. You must now prove that ABC is congruent to triangle DBC. Now it looks a bit difficult to see the two triangles over here, so I will actually color them in. Yes, A, B, C. This is the one triangle. Okay. Let's take another color, red. Prove that ABC is congruent to DBC. So DBC will be this one here. It's going to be quite a bit difficult to color it in, but I'll try. D, this one, and we'll put a line over here. So we have two triangles there, a red one and a yellow one. Right, let us concentrate on this yellow one quickly. You see, in the yellow one we have a Y And in the red one, we also have a y, which means these two angles, they are equal. In the yellow triangle here, we have a x. You see there? There's x there. And now we look at the red one again. And this x belongs to the red triangle. Can you see there? And lastly, we have this side here, BC. Now BC belongs to triangle ABC. And BC belongs to triangle DBC. So we have two angles and one side. So you can actually see that they tell you here BAC is equal to BDC. So we have that information now, that these two angles, they are equal. That two angles, they are equal, and this side belongs to both triangles. Right, can you see that? Right, let's start. Oh, you know, I forgot to put this answer in. Right, so there you have. Did we skip this one now? Okay. In this diagram, triangle BAC is equal to triangle BDC is equal to y, and that is x. So prove that triangle ABC is congruent to triangle DBC. So we start. In triangle ABC and triangle DBC, BC is equal to BC over here, and that's common. Then we have angle BAC is equal to BDC. Now where's BAC? BAC is over here, so it's actually given to you there. Right, so therefore we have that reason there given. Then DBC is equal to ACB over there, and that's also given. For that reason, triangle ABC is congruent to triangle DBC. Angle, angle, side. Right, next one. Right, so here we have, in this figure, also look a bit complicated, but it's not at all. In this figure, BD is parallel to AE. So don't forget that two parallel lines there. Right, can you see them? And AC is equal to CE. AC is equal to CE. There's two sides, they are equal. And BC over there is equal to CD. So you must prove that triangle ABC, this one, ABC, right, I'll make it 1, is congruent to EDC. EDC. We make that triangle number 2. So you must now prove that these two triangles, they are congruent. So what do we have so far? Right, we have that side and that side. So we have a side. Two sides are equal. In this triangle, this side, and in that triangle, that side, they are a match. Side, side, side. So the third one must be an angle or a side. Now it won't be a side because there's nothing to show us that this side is equal to that side. So it'll have to be an angle. Right. Now you see, because these two lines are parallel, we can actually... Now before we start with the third one, let me first write down the first two. BC is equal to CD. It's given. Then AC is equal to CE. That's also given. Right. Now we must get the third one. Now we see this angle is 80 degrees. And we have parallel lines. So it will be possible to find that one there because they are alternate interior angles. You see, this line is parallel to that line. So it's from this line over here, from the parallel line to this transversal, parallel line to that transversal. So that angle is equal to 80. Right. So we have now the one. Now we need this one also to prove that the two triangles are congruent. Now how to get there? To get there, we must first find this angle here. Now it's quite easy because these two sides are the same, and we know from our previous knowledge in an isosceles triangle, when the two sides are equal, the angles opposite the equal sides, they are equal. So this one must be 80. And once we have this one, then we can move there. Right, because now we know that these two lines are parallel. So if this one is 80, that one is also 80 because they are alternate interior angles, the same like this. But you must show step by step. This one is easy, but to get to that one, you'll have to show step by step how to get there, and you must give reasons. So you see, we start like this. Let me first clean that eraser. BCA is 80. BCA is 80. They say there. Alternate interior angles, right? Because BD is parallel to AE. So we have that one, A. Then CEA is 80. CEA, this one, is 80. Angles opposite equal sides. That is how you write out your reason. Angles opposite equal sides. Then thirdly, you're not there yet. Now you say that DCE is equal to 80. Right? Alternate interior angles because of BD that is parallel to AE. Now you get to the third element of our congruency. Therefore, BCA and DCE, they are equal. Right, you don't need to give a reason here because you already gave two reasons to get to DCE. Right, so therefore BCA is equal to DCE and the triangles are congruent. Why? Side, angle, side. Side, angle, side. Right, now the last one. Okay, you can see here, this is actually two adjacent sides are equal and two adjacent sides are equal. If you still remember the rules of the quadrilaterals, you will see this is a kite. So, A, B, C, D, A, C, B, D, or what is a kite? AC is equal to CB, AC is equal to CB, and AD is equal to BD. Prove that CAD, so you must now prove that CAD, this triangle here at the top, right? Let me take my highlighter. You must prove that this triangle here, alright, is equal to this one here at the bottom. Okay, let me just erase it again. So you must prove that this triangle here is equal to this one over here. This one, CGB. Right. prove that CAD, this triangle, is equal to CBD. CBD. Where do we start? We start with the two sides. This side is equal to that side, so we have a side. That side is equal to that side, so we have another side. And of course, the one in the middle is common. It belongs to that triangle, and it belongs to that one. So we have side, side, side. But if you remember still the rules of the kite, or the properties of the kite, then you will also know that the two angles opposite the long diagonal, they are equal. This two here. So it can also be side angle side, side angle side. You can use any one of these two. I used side, side, side. So in triangle CAD, CAD and CBD, AC is equal to CB, that's given to us. In AD is equal to BD, that's also given. And lastly, CD is equal to CD, that is common. So triangle CAD is congruent to CBD, and it's side, side, side. So we come to the end of this lesson. So if you didn't fully understand this work, watch the video again, and then you subscribe and like my channel, and you will receive more lessons in future. Thank you so much.